Section 9.5 covers inverse functions. So the first thing we need to review is what is a function. If I were to draw a random graph, so here's my graph, and label it f of x. So it's a function of x. I know this is a function because for every value of x, there is exactly one value of y. This value of x right here, that point, that f of x, that point right there, has exactly one value of y. Now a non-function might look something like this. That's a non-function because for that same value of x, I have two values of y. Right here, here's a value of x, 1, 2 values of y. If you remember, we would call that the vertical line test. Vertical line test basically says if I can draw a vertical line through my graph and have it hit 2 or more times, we call it a non-function. So in this case, my black function is 1. It qualifies because anywhere I draw a vertical line, I'll have 1 hit. My blue graph, this blue relationship, is not a function because, again, it fails the vertical line test here. It fails it here. The only place it doesn't fail is right there. Another example of checking to see if something is a function or not. Now, this is review. Here's my relation. So it looks like a parabola. I check by drawing a vertical line. If the vertical line crosses the graph more than once, it's not a function. If I look, anywhere I'm going to draw this vertical line, I'm always going to have one point of intersection. That one point means I am looking at a function. Now, I don't worry about horizontal lines yet. Even though I can draw this horizontal line here and get 2 hits, this black relationship is still considered a function because I'm only worried about vertical lines for the given graph. What we need to start doing now is actually talking about how the inverses are related. If you remember from our previous work, the inverse is the undoing of a given function. So here I have function f of x. As I go left to right, it rises, cuts through here. I know it's a function because I can draw a vertical line that only crosses the graph once. So it passes the vertical line test. When I want to talk about the inverse, what I'll be doing is taking this graph and flipping the x's and the y's. So the inverse would look something like that in blue. That would be the inverse of f of x, or f inverse x. I now want to ask myself, does that pass the vertical line test? When I draw that vertical line, now I'm drawing them in blue, is there any place it's going to cross more than once? The answer is no. If throughout my blue curve I find I only have one point of intersection, then the inverse is a function. It's important to note that every function has an inverse relation. So every function has some kind of inverse. That is to say that there's some rule I can do that will undo what the function did. For example, x squared might be my function. The inverse relationship would be to take the square root of that. Just because there is an inverse does not mean that inverse is a function, though. And that's what these questions are going to be focusing on. I know I can undo any mathematical operation. I know that if the function has to do with taking the log base 10 of some number, I can do the opposite of that. I can take 10 and raise it to that power. So function inverse. The question is, when are these inverse relationships going to be functions themselves? There is a shortcut to determining whether or not a function has an inverse which is also a function. So let's go back to our basic squiggle. There's my f of x. Now I can look at that and think about what it would look like when I draw the inverse. But there's another method. The vertical line test will tell me whether or not this relationship is a function. I can then draw its inverse. The inverse is going to look something like that. But, and if I look at this, I can see that's not going to be a function, is it? Vertical line test is going to fail. There's another method. If a given relationship passes the vertical line test, then it is itself a function. If it passes a horizontal line test, then the inverse is a function. So without drawing the inverse, I can see a horizontal line, 3 points of intersection. My inverse will not be a function. Here's another example. My function, f of x, is my old quadratic that I know and love. I also know the inverse then is the square root of that. So I know going in what that inverse is going to look like. I know it's going to look like that. But let's not think about it. Let's do the two tests. Vertical line test. Confirms that the original quadratic is a true function. The horizontal line test when I draw a horizontal line through here, 1, 2 points of intersection, my inverse is not a function. And when I look at the graph of that inverse, I can see 1, 2 points of intersection. So the actual graph of the inverse itself does fail the vertical line test. So let's recap our tests. The original function, I'm going to take my original function and test it with a vertical. The vertical line tells me if it's a function. When I test the horizontal line, that will tell me if the inverse is a function. Now remember, every function has an inverse. The question is it a function itself or not? So again, in this case, my f of x in the black marker, my inverse in the blue, when I look at the f of x, vertical lines intersect once, horizontal lines intersect once. Therefore, I know before I even draw it that the inverse is going to follow the function rule. Horizontal line on my original, inverse function. Vertical line itself is a function.